So, when you have command of a ship, a big one, you need to steer it. The problem is, when the rudder itself weighs many tons and is subject to hundreds of tons sometimes of hydrodynamic force, you need either a wheel of immense diameter with 10 people to turn it like they had on some of those Long Island Sound steamers, or you need the assistance of a steam engine. Right now, we've got control of it by hand in case the engine fails. But the way we would work this normally, we just put it in midship. See the quadrant that indicates? Of course, the starboard is that way, and there's the rack that drives it up top. See? So, we'll go back to mid. We'll clutch in the steam engine instead. Now, this spins freely. There's no turning on the rudder. This is a computer. As you can see, it only goes in the direction I tell it to, as far as I tell it to. Even a quarter turn or one turn of the crankshaft, you see? It's very controllable. The way it works is there's a computer in here. A very simple computer. It's made by a screw is its first component. The second component, just like that winch, there is a four-way valve in there. The four-way valve switches the admission and exhaust. It's also a throttle valve. So if it's in the center, no steam goes anywhere. If it's to one side, steam goes down the admission port and exhaust port one way. And if it goes the other direction, it flips the exhaust and admission logic. There's piston valves. So if you offset the valve from center one way, the engine will turn starboard. If you offset it the other way, it'll turn port. The way you offset it, as you'll see, when I turn the small wheel, I turn the screw inside of the screw collar. And you'll see I make the valve move up and down. See, the valve rod doesn't rotate, only the screw does. The way it works, when I turn the screw and move the valve one way or the other way, the engine will want to run. But when the engine runs, it turns the screw as well, back the other direction. Or I should say, it turns the screw collar. So when I turn the screw, the engine will run and turn the screw collar and move the valve back to center. So the engine always seeks to find the center. And of course, at which point, when the valve reaches the center, the engine stops because the steam flow is shut off. So that's the computer that operates the steering engine. And you'll see it just takes the force of my hand and magnifies it by many horsepower. Look, 2 fingers. So the command of my fingers is being magnified into enough force to move an immense rudder. It's just a force magnifier. Cars have power steering that work in a similar way with hydraulics and a hydraulic pump. Now, you'll see quite a lot of steam gets by it even when it's stopped. That's for 2 reasons, all right? The valve of a steering engine always needs to let a little bit of steam by to keep the engine warm, because there will be periods of time where the ship's rudder does not move on the open sea, sometimes for hours, or at least periods of 15 minutes, 20 minutes between course corrections. If the engine remained stationary for that amount of time with no steam flowing through it at all, of course, the next time you went to steer the ship with a steam power, the engine would digest lots and lots of water slugs and blow its heads off. So you need a flow of steam always going through the steering engine to keep it warm and ready to work. It needs to be ready to operate at any command at a moment's notice. The other reason why it leaks that much, the amount of steam going through it should be far less than this, but unfortunately, Most of these steering engines, especially this one, saw a very hard service life. They didn't get proper lubrication to that piston valve, and they just wore to the point where there's a lot of leak by. And in a ship like a tugboat especially, we're just working all the time and doesn't have access to a big fitter's yard, and where they didn't care that much by the end of the steam era, these engines all got like this. Now this is a pretty bare bones one. If you would go to a steam liner, you will find 3 HP steering engines with 3 cranks at 120 degrees. The Olympics had something like that. And they, of course, would be maintained so there'd be hardly any leak by at all. Some of them would have automatic drain valves and things like that. This one just has a pair of cylinder drains right down here. But, and of course, like on any ship, this would exhaust into the condenser, so it wouldn't fill your wheelhouse with steam, and you get a bit of a horsepower boost from the vacuum. But that is a steering engine, quite a nice one, from Donkin, Walkergate, Newcastle upon Tyne. And the last engine we have to show you, it's actually fairly special to me because it came from my friend Dick Gibbons. We'll see if we can move the hose over to it and get it operating.